Hello, good evening, or as they say in America, good day to you. And I would like to welcome you and hope you're sitting comfortably for this great webinar. Now, my name is Dalim. I am chairman of BCS North London branch and London Central branch. But as far as I'm concerned, we're heading towards Christmas, aren't we? So I'm tucking into my Advent chocolates in my calendar here, and I'm looking forward to opening all of these doors and being able to enjoy the contents. And I hope you're looking forward to Christmas too. Now, we haven't got any snow here in London, but I do want to give you a teeny bit of a glimpse of what we've got in general, and then hand you over to our presenter, Ulf Mattsson. Ulf is part of our BCS regulars crowd, as it were. He's becoming a great favorite of ours, and hopefully we are of his too. This is another of the webinars in the series that we've got relating to disruptive technology, the future, and you. So what we're doing this time is looking in some detail at blockchain with Ulf. And Ulf is the chief security strategist for Protegrity. He is actually based not here, but in the US, but a little bit more of that in a minute. He's the author of many articles for ISACA and other journals. He's an inventor with over 70 issued US patents. Wow. He also helped to develop some industry standards with ANSI, for example, and PCI. So thank you, Ulf. Now, his talk that we had way back, you may recall, data protection, security, and privacy. That's very much Ulf's field. But what I'd like to say is that Ulf is not here, as I mentioned. He is actually in Connecticut in the US. So we've got the marvels of our we've got the marvels of our webinar technology helping us as well tonight. But Ulf, welcome, and tell me, you're in Connecticut. How is Connecticut right now?
It's sunny and bright. We have freezing temperatures during nighttime, so we are seeing the winter is coming. In daytime, right now, we have a few centigrades on the plus side, so it's pretty nice.
Great, great. Well, there's one other person who's very much a part of this webinar, and that is my BCS colleague, David Grundy of London Central Branch. He is the technical controller behind this, but also he is going to be asking the questions when you send them in and so on, and he will head the Q&A part of the session after Ulf's talk today. So I have another question for you, Ulf. What is tokenization in blockchain? Please join me in welcoming Ulf Mattsson.
Thank you. Yeah, we will talk a little bit about that today. So hello and welcome, everyone. And I'm very excited about tokenization. And I think blockchain is starting to be real, starting to be more and more important. So I would like to talk to you about that today. So a little bit about my background. As mentioned, I'm involved in developing industry standards for financial industry in US with ANSI X9 in the areas of quantum computing, tokenization, cloud management, and security, crypto, and tokenization. And I'm also involved in Cloud Security Alliance in providing guidance for data security and cloud security. I've been involved in developing the payment card industry's security standard for many years in the areas of encryption, tokenization, cloud, for example. And I recently published a couple of articles in the ISSA journal about data security, on-prem and cloud, and data privacy, about de-identification and anonymizing PII data and other sensitive data. And I also have an upcoming article in the ISACA journal coming in January with privacy preserving analytics and secure multi-party computation. And my earlier article from May this year talked about practical data security and privacy for GDPR and the California CCPA. I'm in, on the left-hand side at the top, you can see I used to be a chief technology officer in different companies. I was an IT architect at IBM. I worked in cloud security companies. And on the left-hand side, you can also see that different product areas that I worked in, CASB, WAP, SOC, managed security services. And I've been focusing on research and development for many of the years. And I would like to talk about the topic in three different areas. So today's topic is, of course, blockchain and tokenization. So I like to start off with a definition. What is blockchain? A couple of use cases, some trends and risks with implementing blockchain. I will touch on vendors and platforms a little bit to make it to connect to what can you actually do, what are companies doing out there. Then I want to talk about scalability. Scalability is important. When you talk about blockchain, it's a struggle with scalability, so we'll talk about that. And of course, when you put data on blockchain, it's not protected. You may have the chain protected. There are hash fingerprints on the transactions, but your data, you need to be careful about the data. So we talked about that. And tokenization. Then we'll talk about different aspects of tokenization. If you tokenize an asset, you may do digital business, and you also have different models of tokenization. And we'll talk about the local central type of models that you can apply for tokenization and how they fit together. And finally, I want to talk about cloud. So more and more organizations are moving to a hybrid cloud. And what does it mean? What do they do? How do they apply tokenization to a hybrid cloud? When I talk about hybrid cloud, I'm thinking about you have a mix of on-prem and cloud, public cloud, for example. And I will talk also about the multi-cloud, where you maybe have some of your services running on Amazon AWS, some on Microsoft Azure, and some on Google maybe. Maybe you do analytics in Google. Maybe as a developer, you like AWS because you have more than 100 functions. You have Lambda functions. You have so many features that are exciting in AWS. And if you think about Microsoft, you have a Windows environment, then Microsoft Azure can be a simple path to cloud because they have the Active Directory. They have a lot of the terms, terminology, very similar to what you are used to on-prem in a Windows environment. What is blockchain? So blockchain is a chain of blocks. At the bottom, you can see they are linked together. So we have a couple of transactions here. It should say block 1, 2, 3, 4. I will fix that. And they are fingerprinted. So the integrity of the blocks is there. So you cannot go back and change a block, change the transaction. So it's giving you a nice ledger, immutable ledger. It gives you the integrity. You have data lineage where you can see where did the data come from, what transactions, who actually did a purchase. for example. We'll go back to that. At the top, you can see a simple example of transactions used for a network member, manufacturing, shipping, and the different transactions are tracked and recorded on blockchain. So blockchain is basically 5 different things. It's about distribution. You use and typically use encryption to secure some of the information. Immutability, you write it, you cannot delete or update your transactions. And tokenization is something that is evolving, so we talked a lot about that. And the whole idea is decentralization. So you have a peer-to-peer model, and we will discuss the different models. So Gartner is saying that the strengths, weaknesses, opportunities, and threats could be listed as you see here. So we talk about the strength, how you can do it, the weaknesses, what you should avoid to do. We talked a little bit about opportunities. What are companies doing with blockchain and transactions on blockchains? And then you have the whole legal system that is starting to wake up and realize that this parallel universe is actually starting to work with things that are maybe regulated by different organizations, institutions, and governments. So we'll talk a little bit about that aspect also. So blockchain could be public, everyone can access the blockchain, or it could be controlled. So you have a private where you control access to blockchain. And there are different use cases for it. So at the bottom, you can see Bitcoin. We talked a little bit more about that. Ethereum as a big platform, more general platform. And if you talk about trust, blockchain provides a new way to trust, the decentralized trust model, where you don't need to go to a central authority to register and rely on that trust. It's a peer-to-peer model. It's decentralized, and we talk a lot about that. And it's easy to use because it's not a database, not just a database. It's another layer of functionality, another layer of features that you can benefit from. If you're a developer, it's a lot of functionality you get for free, functionality that you don't get from a data store, a database, for example, but it's not a database. Here we have a couple of startups. It's happening in the startup community a lot. So blockchain and distributed ledger technology is reported by Computer World as exploding in the exchange world. You have that on the left. You have Coinbase, for example. In the middle, you have tokens, you have Dash, you have Ripple, and other companies. You have Ethereum. On the right-hand side, you have smart contracts. That's a big evolving area that is utilizing blockchain platforms. And on the right-hand side, you can see companies that are more core blockchain developers or providers. So use cases, I think it's always good to start with use cases. Look at use cases. What are people doing? A couple of countries. If you go up to the left, you have healthcare from US. So healthcare is seeing a great use, starting to explore blockchain capabilities. On the right-hand side, at the top, you can see a completely different application of blockchain. They manage ship and plan shipping. And at the bottom, you can see a very powerful tokenization, or I would say mainly distributed ledger use of blockchain. I would say the government is running on blockchain in Estonia. They are doing a lot of interesting projects. They were early on utilizing distributed ledger. More examples. This is more enterprise focused. You have companies like Toyota in the car manufacturing space. You have shipping services like United Parcel Services in US. On the right-hand side, you have the booming connected cars industry. Again, with Toyota, you have Mercedes as examples here. This is from Computer World again. They are listing 50 enterprises that are utilizing blockchains. On the right-hand side, you can see who they listed, and we'll talk more about some of these companies. On the left-hand side, you can see companies that are investing in logistical applications based on blockchain, for example, Oracle and SAP. What are they using? So these are major blockchain platforms used by enterprises. At the top, you can see, for example, 27 of these companies that we talked about before. They're using Hyperledger as a platform. 24 are using Ethereum, 9 are using Corda, 9 are using Bitcoin, and so on. And next down, you can see a range of different platforms, Waves, XR, and so that are used by fewer companies. But there are many platforms that have different focuses. So on the left-hand side at the bottom, you can see companies that are using a combination of Hyperledger and Ethereum. Enterprise customer A, they are using that combination. And if you go down, you can see company A, they are also using that combination. Then you can see a group of companies that are Bitcoin focused. On the right-hand side in that table, you can see the combination of using Bitcoin together with Ethereum. On the right-hand side at the bottom, you can see Ethereum is positioned as an independent platform. If you go up, Hyperledger is very flexible, extendable, used by different various industries. And Corda at the bottom center is focused on financial services. So you can see on the left-hand side at the bottom, the last two companies, UNV, they're using a combination of Corda together with Hyperledger and Ethereum. So why are they using the combination? It's because they are different. If we still focus on Ethereum, Hyperledger, and Corda, you can see what type of platform and mode of operation and specific characteristics. And in this chart, you can see potentially why are they using all three and a combination of some of these three. So Gartner and Springer is showing this procurement that is tracking shipping. So this is related to what we talked about in the beginning. So they are tracking via RFID what is happening to different shipping, and throughout the process they can see exactly what is happening, and they are using blockchain to track this. Gartner is listing 11 use cases. Asset tracking, number one here that we talked about earlier. If you go down, number 6 is payment settlement, where you have a ledger for your transactions. And number 7 is interesting, provenance. I mentioned data lineage that where you actually can have a record of what happened to your asset. what happened to your purchases, or who actually made these different transactions, and it's immutable, so you have a safe way of keeping that ledger. And at the bottom you can see some trading and finance applications. Number 9, for example, is what we saw in examples from Tallinn, and they are using blockchain for tracking and control functions in the city. A lot of IoT devices that are connected to the blockchain platform. More about different companies in fintech. Up on the left, you can see, for example, Square. Payment transactions, they are utilizing blockchain. Connected cars, we talked about them before. Retail, to the left top, you have companies like Walmart, big retailer in US. At the bottom, you can see companies that are using it for HR, storage, logistics that we talked about before, supply chain, SAP, asset rights management, like DRM, we used to call it DRM. IoT, we mentioned a little bit about that. Energy is a growing sector to the right, and you have loyalty and advertising to the right, the bottom. Gartner is saying that blockchain can potentially reshape industries. It will enable new business models, a new way to develop applications. And I love that. My background is a developer, IT architect, and I love that aspect of it. We will talk a little bit about identity management in a minute, where blockchain can play big time. Gartner is saying that the following value drivers are identified, and we talked about a couple of examples before, so this is more as a reference. You can go back to the presentation and read more about it if you want to. Also, Gartner is saying that this is a map of how they view tokens, how they are used in different aspects of using tokens. For example, you can see digital wallets in the middle, and you can see usage of payments and other type of transactions. So it's a wide field of use cases. 7 things that you should not do. We talked about misunderstanding a little bit. Look at number 4. It's not a database. You cannot really use it as a database. You cannot delete, you cannot update information. It's an advanced log file or ledger for specific type of use cases. Many use cases, but they are not typically database use cases. And we will talk about some of these aspects throughout the presentation. Interoperability, for example, which is a weak point, and as Gartner pointed out before. What is our board saying about blockchain and in particular Bitcoin? So this is from Gartner, where they ask, to what extent are Bitcoin and blockchain a risk or opportunity to your organization? You can see the green. So the board members said the opportunity is 54%. The risk, total risk, is 28%. So typically they like things being utilizing blockchain. Digital business. Let's talk about tokens and assets. So you can transform assets into token values. On the right-hand side, you can see examples of assets real estate, energy mines, antiques, and more. On the left-hand side, you can see examples like a Picasso painting, gold, diamonds. So you basically can buy a token in that asset. You buy a piece of it. Stock options may be tricky because you can typically not sell a fraction of a company share. At the bottom, you can see 3 companies that are focusing on different aspects of assets and token trading. Capital markets at the bottom, and we talk about paintings. You can see the middle one at the bottom, focus on paintings. What about real estate? Tokenization of real estate. So you have an apartment, let's say $200,000 on the left-hand side here. On the right-hand side, you split it up into different owners owning different tokens in that real estate, different shares. So it will allow smaller investment to get into an asset. In this example, they are mentioning Ethereum as a platform. And at the bottom, it's important to keep in mind that you are not becoming the legal owner because of having a token. It's a track record. It's a ledger where you can record ownership. You can record your transaction, and it cannot be easily erased. For example, you need to take over more than 50% of the blockchain network to compromise it. Legislation and central, we mentioned that in the beginning. There are legal challenges and changes are needed. It's a battle between this distributed peer-to-peer model and the central authority that want to control, and they want you to certify to make certain types of, let's say, financial transactions. So this is an ongoing battle, and more people on the legal side are starting to open up, wake up to blockchain and how it's spreading into more and more industries and use cases. What is happening with blockchain? We have heard about blockchain for ages. Is it going anywhere? Is it stuck? Did it not happen? We have heard Bitcoin, it dropped, and they are running into a wall of scalability and so on. But blockchain is much more. Gartner is saying that we are just in the middle of this curve. So Gartner is expecting the worldwide business value to really ramp up in a couple of years and go very high. Gartner's report last year, the CIO survey, stated that or reported that 60% of CIOs expect some kind of blockchain deployment in the next 3 years. And the industries on the right-hand side at the bottom, you can see the split between financial services and general services and transportation pretty evenly. 4 types of initiatives. You have the maybe least exciting on the right-hand side, just as a record keeper. But on the left-hand side, you have the disruptor, where blockchain can enable new business models. And in the middle, you have, for example, efficiency. It can be very productive to use blockchain as a platform to develop on. At the bottom, you can see predictions about blockchain-based applications. 80% of enterprises will fail with that. So we talked about ways to not succeed, ways to fail with blockchain, and we should keep in mind that there are limitations. It's not a silver bullet by any means, so we should be careful about what use cases we pick. Gartner is looking at different blockchain technologies. So this year they said, for example, tokenization is up there on the right-hand side. At very close to the top, you have decentralized identity at the peak. We talk a little bit more about that. And on the left-hand side, you have the blockchain as the tokenization. So we talk a lot about that. What about identity management? We are using TLS, SSL, maybe not anymore, but we used to use SSL. And we're using HTTPS, and those standards are representing a centralized identity management model. That's the number one at the top. We know that federated identity is a model where you have a central identity provider in the middle, the bluish one, and standardization is provided by SAML, OpenID, Connect, OAuth2, for example. And the interesting part, I think, is at the bottom, where you have a new identity management model that is not centralized. It's a peer-to-peer model. It's utilizing blockchain as the protocol, and this approach is typically called SSI, self-sovereign identity. And you have organizations like IETF and W3C that are standardizing on this technology. There's a company name on the left-hand side at the bottom that I picked this information from. Gartner is saying that blockchain will be scalable in a couple of years, and I'm looking forward to that because we have seen scalability problems when the blockchain is increasing and the chains that you need, chain of blocks that you need to compute and verify gets long. So it can cost a lot of energy and computing power to do those calculations. So we have seen with Bitcoin that it could be more costly to actually do the compute than the value of what you are computing. So that is changing. And Gartner is predicting that scalability will come, new types of consortia, and the roadmap is on the right-hand side, what they predict in different aspects, for example, data confidentiality and efficiency. What about security? Securing blockchain. Blockchain, we talked about, you can have a private model that will only let in people that should access your private blockchain. So you control it, and then you have the public model where you cannot restrict people to get in and publish on your public blockchain. Is it impossible to hack? It's pretty hard to hack. You can look at different attack vectors. If you want to go in and manipulate information in the blockchain, you need to take over more than half of the nodes in the blockchain. And there can be a large number of nodes in a public blockchain. So from that perspective, it's pretty secure. You are not relying on a centralized place that can be hacked and compromised and manipulated. So the strength lies in the decentralized model. It's encrypted, it's hashed, so it's there's a fingerprint, and it's the network is verifying that not one node is broken. So it's the decentralized linking that provides that security. Tokenization. We'll talk much more about encryption and tokenization because the information you put in blockchain, it needs to be secured if you care about the confidentiality. So we talk about ways to secure information, tokens that you put on the blockchain. There are many different data protection techniques. Some are similar, but there are big differences. So let's start with some use cases, simple use cases. On the left-hand side, you have payment applications, a call center, and at the top on the left, you have Salesforce. And a gateway is tokenizing data before it goes into Salesforce. So that is a confidentiality play where tokenization is used to protect the confidentiality and integrity of information you put, in this case, Salesforce. Any cloud, I would say. On the right-hand side, you have other data protection options. You have data warehouse. You have models that are used for de-identification, like differential privacy and k-anonymity. On the right-hand side, you have your dev test system that typically is using masking. At the bottom right, you have homomorphic encryption, for example, used by Microsoft Election Guard. So the PI that I'm referencing here is using the term that was defined in the California CCPA, where they say that personal information is not just about an individual, it's about the household. Any information that can be reasonably linked, even indirectly, to that household is covered by that regulation. And I view that as a trend that is going beyond what we typically view as PII in, for example, GDPR. GDPR is very focused on the individual, the identity, and the rights of the individual to personal data. So you see a trend that is going beyond that. It brings in a reasonably linked. It brings in the aspect of inference. If attributes in your data could indirectly link to the identity of a person or household. So we'll talk more about that. Two very simple use cases. On the left-hand side, you de-identify data. You have a name, a balance, age, and gender. So we are applying generalization and pseudonymization on the left-hand side. And at the bottom, you can see examples of what the data would look like after you de-identified the data. On the right-hand side, at the top, you can see a similar use case. This is a patient ID, and we protect the age and the region. So we are applying generalization to those attributes, and you can see the blue arrows pointing to what the data looks like after that de-identification. And when the data is de-identified, it's no longer regulated. that data is no longer covered by GDPR or potentially whatever regulation you are under. Here we have a couple of different protection models. On the left-hand side, you can see reversible two-way protection models. On the far left, you can see tokenization, which is a very fast way to randomize your data. Then you have FPE, format preserving encryption. It's also format preserving, but it's algorithmic. So there's a key, encryption key, and an algorithm. It's about 10 times slower than, for example, AES 256 encryption, because FPE is using typically 10 rounds of AES or similar blockchain, block cipher encryption. Then you have homomorphic encryption, which is very slow, getting faster, but it's a special use case. So typically you encrypt your data and then you operate on the encrypted data. So you're not waiting for decrypting the data. So 2 encrypted values could be added without decrypting the data, and then the result is decrypted. So you get the clear text result of that operation. And it's restricted to not all operations, but typically you can do addition and multiplication on homomorphically encrypted data. On the right-hand side, you can see the hashing, masking, and other fast one-way, non-reversible operations. And far right, you can see k-anonymity and differential privacy. They are typically adding noise to your data. You saw in the model a minute ago where we added noise to generalize the data or de-identify the data. And it preserves the format, so typically it can be very nice to handle for an application or database. The type and the format, data type and format and length is typically preserved. And all these techniques that are linking down to analytics and machine learning are useful for different use cases. Over the years, we saw strong encryption. We saw format preserving encryption, which is a little bit softer, and there are improvements of format preserving encryption to make it more secure to handle shorter data strings. For example, there are issues with, let's say that NCX9 is recommending that data shorter than 9 bytes should be very carefully scrutinized. So you are using the right tweaking and not producing weak ciphertext. At the bottom, you can see the vault-based tokenization and vaultless tokenization. They are different, but the data looks like format preserving encryption. And if you look at tokenization in general, it can be used for a lot of PII data, a lot of health information data. A number is a number, a name is a name, and you can tokenize that. Then you have X-rays and other files that you may just want to encrypt. Tokenized data could look like the right-hand side here. So you decide what part of the data do I want to protect. Maybe the application do not need to have access to the full credit card number. And then I've tokenized part of the credit card number. So the application can actually operate on that data, in many cases without any changes. It's very flexible. And the whole idea is to bring down the risk. So the reason why the PCI, the Payment Card Industry Standard, recommended tokenization is because you can share the data with a lower risk. It's a random replacement of the data. And by allowing a lot of data to be accessed by the user, you can keep the user productive and creative, and still contain the risk level. This is a case study from an international bank in Europe that needed to comply to very strict privacy regulations in Germany and Austria, for example. They were sharing financial data and personal data, very sensitive data, and they chose tokenization because it was a cost-effective way of sharing that data and not impact business operations and still be compliant to legislation. The newest way of doing tokenization is to create a fabric. So at the bottom you can see one German example of a fabric where the different pieces of the data is linked together to create a secure fabric, or a fabric that will secure the different pieces of data. And you stay within the language. On the right hand side or in the middle, you can see how it applied to Asia, Japanese kanji or other hiragana and katakana, for example. You can see a mix of those languages in this picture. They are secured by using this tokenization fabric. Very international, applies to Unicode. On the right hand side, you can get the idea that this model is very scalable. It scales down to smallest devices like IoT devices, and it's applicable to the cloud, which is very important for many organizations. What about different types of encryption and tokenization? Performance can be a showstopper. We have all heard that encryption can kill the performance. So how much performance can you get out of different techniques? Here we have transactions per second. So in a data warehouse, you probably expect 10 million transactions per second. Other applications may just need 1,000 transactions per second. So in that case, you may want to use the old vault-based data tokenization, which is based on a central database that you need to access, and you have the database access. And so if you go to the far right, you have a memory-based tokenization that is much faster. You move up from 1,000 transactions per second to maybe 10 million transactions per second, 1,000 times faster. And it's the same or very similar speed to AES, cipher-block chaining, 256-bit key encryption. And then you have a little bit to the left in the middle, you have format preserving encryption, which is a little bit slower, about 10 times slower than AES, because it's typically using 10 rounds of AES encryption to perform a format preserving result. or length preserving. It's the number of rounds is typically required to preserve the length of the data. And of course, depending on your environment, your platform speed will be different. If you go to an AWS implementation, you may get 20 million transactions per second instead of 10 million, for example. We talked about that the different models are very different. It sounds like tokenization is tokenization. No, vaultless, if you measure a handful of properties on the left-hand side, what about the footprint? What about replication of your data store? What about collision? What about performance? We talked about performance and latency. And what type of data is it applicable to? So you can compare the vaultless that happens in memory on the right-hand side with two approaches to vault-based. So vault-based is based on a central vault. If you have a distributed vault, you can see here that replication can be complex and cause delay, and you may have synchronization issues. So they are not really synced, and you can mess up the data integrity. So that's a dynamic. It grows for every tokenization you perform. It's growing database. And in the middle, you have a pre-generated that is basically a big database of all possible values, which may be too big for some use cases. You want to reduce risk because at the end of the day, it comes down to business risk. That's why we have security. That's why we do security and privacy. You want to reduce the risk of non-compliance, the risk of a data breach, and a lot of more and more liability that rides on protecting your data. So this map is showing how the type of data techniques, data protection or de-identification techniques on the left-hand side that we talked about quite a few of them before. So on the right-hand side, you can see what good are they? And on the far right, you can see what type of risk are these techniques actually helping me with. Far right, you can see the inference risk. When I said, for example, the California regulation and GDPR, both are concerned about inference risk. And inference risk could be that I'm the only guy with a yellow car on this particular street. That data could infer and indirectly identify me. So that risk is handled more or less, partially, for example, by the yellow ones. And then you have other risk reductions, linking, singling out. This is based on an international ISO standard, 20889 standard. And in the middle, you can see when is it applicable. The different techniques are typically applicable for data in transit, data in use, or data in storage. And you can also see here what type of attributes are they applicable to. Some are applicable to direct identifiers, some to all attributes, green ones, and some for just local identifiers. And the middle column, data truthfulness at record level, it can be important for some use cases. You don't want to add or mess up your data if you're doing analytics, for example. If you are adding noise, then you may mess up the data for your analytics. You may skew the data and create other disruptions, so you cannot do proper analytics on that data, depending on the use case. A couple of protection techniques on the left-hand side. On the right-hand side, you can see, are they applicable for a data warehouse? Some are more applicable for centralized or decentralized environment. Then you have the cloud aspects on the right-hand side. We'll talk more about cloud aspects. So, is my data exposed in the cloud? Yeah, in many cases, your data is more or less wide open. They may use disk encryption, but who can actually see the data? And what can you do about that? So let's focus on tokenization in hybrid cloud environments. We know that Amazon is a leader in use, and this is what organizations are using or planning to use. On the right-hand side, so you have Amazon AWS at the top, followed by Microsoft Azure, and then Google. And organizations are, as I mentioned, typically using Microsoft Azure if they have an enterprise Microsoft environment and they want to easily transition to cloud. AWS has so many functions, serverless Lambda functions, and other hundreds of APIs and functions. The developers love that. Cloud is typically good with a lot of features for analytics, big data. On the left-hand side, you can see the digital commerce platforms. So Gartner is saying that this is the growth. The blue are cloud-based, and the green are on-premise. So it's definitely happening. These are use cases from a global organization. They are controlling the data from US, the policy control, key management at the top, and that controls what's happening in Europe and Asia at the bottom, where you have, this case, they're using, it's API-driven or API-driven applications, cloud and on-prem. So this deployment model is used both in cloud and in proprietary and on-prem by large financial services organizations. If you shift sensitive client information to Salesforce, you may want to put a gateway that is doing the encryption and tokenization in the middle. So it's transparent to your left-hand side, your endpoint, and to the back-end side. So you control the encryption keys. And at the bottom, you can see it's applicable for on-prem databases and servers. So you basically inject a gateway. That could be virtual, could be a cloud-based or an appliance. Here we are back to Google Cloud BigQuery, showing that the policy and key management at the top that you control is encrypting or tokenizing data before it goes into Google Cloud. Similar scenario for AWS S3 buckets. So we have seen a lot of organizations having problems with S3 buckets, data that is compromised. So in this case, the data at the bottom is coming in and the data is tokenized or de-identified before it goes up to the cloud. multi-cloud, Synopsis and Big ID, they are reporting that more and more organizations need to know where the data reside, how the data is flowing. This picture is from Big ID at the bottom, and Synopsis is saying that organizations are concerned about exposing the data to governments, and they don't want the encryption keys to be available in the cloud or clear text data. They may have GDPR that's saying that, well, you need to be careful. You cannot store the data outside the region. You cannot even transfer the data outside the region. So you need to have a good picture about where the data is traveling and where the data is stored and who can access your data. Many Synopsis is also saying that some organizations do not trust the cloud vendor. They don't know what's happening with administrators and who is accessing the data when it's in the cloud. They want to protect it, as we said. They also are concerned more and more about vendor lock-in, because when you go to a multi-cloud model where we see more and more organizations picking one function from Amazon, another function from Microsoft, third function from IBM or Google, because they find the best business value. So they want to keep their control about policies, encryption keys separate to avoid that vendor lock-in. They want to keep that control, and they want consistency. So if they are managing the keys on-prem already, they want to have the same technique to manage the keys for the cloud. So thank you very much. This concludes my presentation, and let's see if should I stop the sharing here, or what should I do?
Ulf, that's okay. You can continue to share. But David, do you have any questions?
If anybody has any questions, then type them into the question box, and then we will start to go through them.
Yeah. Ulf, this is Dalim. Thank you very much. That was pretty deep, I think. I'm still holding my head and wondering what's going on here. But I could see that there are some major possibilities here, but that we need to understand this whole area much better. Do you find that there is a need currently for more blockchain understanding, more education and so on about blockchain, especially about areas like tokenization and its benefits?
Yeah, I think both blockchain and tokenization are areas that are important to understand, because more and more organizations are using blockchain and tokenization. So it's important to understand, how is blockchain different from my other data stores or my other ledgers and logs, because the blockchain is opening up new opportunities and it brings new risk. We talked briefly about how can you fail, or how are organizations typically failing when using blockchain, and you don't want to be on that list. So it's very important both to look at the opportunities. You see the board level interest is there, so you will be probably asked to step in that direction or start to use blockchain. So you better be educated. It's not trivial. But we're starting to see more and more examples and use cases that we can go back and see, what did they do well? what did they not do well? Then when it comes to tokenization, tokenization is the new way to protect data. It started with the payment industry, so Visa, MasterCard, American Express, and other payment systems. They moved from encryption to tokenization. Why? Because tokenization is more secure. They can control what is happening with your payment in a better way. So instead of putting a payment card number on your mobile phone, they put a token that on your phone, and that token is restricted. It comes with a policy that restricts what can you buy for how much, from where, and what region. So it's a whole policy control about how that payment can be utilized, or so it's better risk control. And then from the payment industry, we are starting to see more and more applications in the PII data, and tokenization is starting to be more and more suitable to protect PII. You get the functionality, flexibility, performance that you need to protect all that PII data that GDPR and other privacy legislation is pointing to. So I think both blockchain and tokenization is coming. They are coming, and we need to be more educated. Otherwise, there will be a lost opportunity, and it can create risk if we are not well educated on these technologies.
Great, thank you, Ulf. David, let's not lose the opportunity to answer some of the other questions that have come in. Over to you.
Yes, we've got a question from Leon. I'm in my third year of university doing my capstone project on blockchains. In your opinion, what type of attack, e.g. 51%, would be the most likely to succeed against a blockchain network?
In my opinion, the greatest risk of attack is that you put sensitive data on the blockchain. So you need to be careful about the confidentiality of the data. So you protect those tokens or that data you put on a blockchain. The integrity is pretty well taken care of by the linking between different transactions in blockchain, the different work group with Cloud Security Alliance. So I'd like to promote that source. And I'm working on a couple of other work groups with Cloud Security Alliance also, and I like to promote that. Even Cloud Security Alliance, they are giving you guidance. It's not creating a standard, but it's a lot of good guidance there. If you want to go in depth, there's a blockchain channel on BrightTalk. The name is the Blockchain Channel. And then if you want to stay at a higher level, I always use Wikipedia to get the basics. And Wikipedia typically have pointers to other sources of information.
Okay, thank you. So a couple of pointers to sources there. Now, another question here. Is there a real future in assets tokenization, for example, tangible assets such as real estate? And how do you know, and how do you develop that in the next 2 to 3 years? How do you see it developing? Who is close to offering a reasonable concept of that? That's the question from Andre.
Yeah, I think it's I think it will be of increasingly importance for record keeping to have an immutable record of your transactions. It will take, if we're talking about the next few years, I think it may take longer before you have legal support for what you are transacting on blockchain. The legal process, as we talked about earlier, is separate. So having a transaction on blockchain doesn't mean that you have the legal right to the asset. So that is up to legislation in different countries.
Okay,
and
thank you. Sorry.
Why I think it will take time is because it's working in competition with some of these organizations that are promoting their maybe monopolistic situation.
Okay, thank you, Ulf. Walter asks the following question. What are a couple of the lessons learned from the failed blockchain projects in enterprises? And how do you make the trade, or how do you make a trade-off between encryption and tokenization? So firstly, are you aware of the lessons learned from failed blockchain projects?
Yeah, I've seen some of them, and what I typically see is that there is a very optimistic expectations that blockchain will solve a lot of problems, but I think it's important to learn from the projects that blockchain is helping you with keeping track of data and transactions, helping you to develop. But it's as we talked about, it's not a database, so it cannot replace your databases, and it will not bring you security or secure storage. You need to add that to your blockchain platform generally. So be aware of, look at projects that succeeded, look at projects that failed, It can be scalability, for example, which is evolving, still evolving. So in a couple of years, I think scalability, we saw the Gartner projection. So in a couple of years, I think we will see more scalable blockchains, and even in the payment space. People are working on it constantly. When it comes to the other question here, encryption versus tokenization, I mentioned that there's a reason why the payment industry favors tokenization. For example, the PCI Council is promoting tokenization over encryption. And if you tokenize the data, you are replacing the data with a random pointer to the data. So the data, it's no longer regulated data. For example, PCI, it's no longer cardholder data. Only if you have access to the data, real data, or access to decryption or detokenization of the data, it will become in scope or regulated. But if you have a segmented system with no access to the real data, then it can be taken out of scope, meaning that you are no longer required to be audited for PCI compliance. And I'm seeing the same aspect for PII data, where organizations are realizing that if I remove my regulated data and replace it with random pointers, replace the regulated data with tokens, it's no longer, that data is no longer regulated. It's like GDPR is saying if you pseudonymize the data, it's no longer regulated by GDPR. And tokenization is a form of pseudonymization. When it comes to encryption, it's a little bit more complicated because encryption can be strong or weak. And the encryption keys are more widely distributed because you may need access to the encryption keys to do decryption in more situations. So the keys are sometimes all over the place. So from a security point of view, you can contain your attack surface, minimize your attack surface better when you use tokenization.
Thank you, Ulf. David, if you're back,
Yes.
would you like to carry on? Yes. Yeah. And keep in mind that we have 10 minutes left officially until 7:30, but we may ask if we can keep running for another 5 to 10 minutes after that, if Ulf is happy to do so. So please take over.
Okay, so the question from Rashid, are you envisaging any application using blockchain in the ERP world? And are there any existing examples?
ERP, I think that all applications that are recording transactions can potentially benefit from blockchain. It provides a layer of functionality that you typically do not get from a database. It's a distributed model where you have the integrity of the data, the chaining provided to you. So I think ERP can be an interesting area. I cannot recall projects that I've seen for that, but I can envision that it will be an interesting application area.
Okay, we've got a question from Sue. With more central banks considering implementing their own digital currencies, how could that impact blockchain design and use? Given the quantity of computing needed, could net zero carbon targets influence the design and use?
I think it can be very helpful in developing blockchain platforms. We have seen China, we have seen UK, we have seen Sweden, and other countries that are moving in an interesting direction. And the hope I see is that more and more banks are getting engaged. So it started to be a two-way street, a dialogue in both directions. So I think it greatly will enhance since financial services is driving. In many cases, it's a strong driving force for enhancing different type of technologies. Like I'm thinking about RegTech technologies for complying to regulations. It came from the financial industry. It was started in London, and it's greatly adopted in New York. It's spreading from fintech. It's not just financial industry that is adopting it. It's spreading to other industries, agriculture, and many other industries that surprised me a little bit about the adoption rate. So I think what the banks are doing will be very helpful in advancing and advancing the technology and also the legal acceptance of using blockchain. So I think it will open up dramatically for a better life of blockchain technology.
Okay, and is the computing power required going to cause a problem in achieving net zero carbon targets?
Say again, I didn't get the first part.
So the computing power required for blockchain, will that cause a problem for achieving net zero carbon emissions?
Yeah, depending on where you do your processing, your carbon footprint can be very different. If you are using green energy or renewable energy, it can help. If you are doing your processing in, for example, Texas or any region that are mainly using non-renewable energy sources, it can be an issue with the carbon footprint. The models are getting better. Blockchain platforms are getting faster and better. But I can see situations where you are running so much computing power that it's a question about if that cost and damage is higher than the value of the Bitcoin, for example, that you are processing.
Okay, we've got a question from Gordon. Do you have a timeline as to when blockchain tokenization will be on our everyday, everywhere use in our society?
If I go back to Gartner, and if we look at their prediction about the worldwide growth of blockchain revenue, it will take a couple of years. I would expect that it will take more than a few years. It will take. I would just expect that within the next 5 years, there will be a very wide use of blockchain technology. Before that, I think we will continue to see the boom in different areas. We in the beginning of my presentation, we looked at different industries and use cases that are already getting a lot of success and traction.
Dalim, I don't know if I've skipped over a question.
You did. It was the one from Uri, but there's one from Stephen, which is right next to you now, and that's also about central bank digital currencies. Do you want to take that one?
Okay, so this is more of a statement than a question. So he's commenting that the central bank digital currency development is not necessarily based on blockchain. One aim is to replicate the anonymity and flexibility of cash. The main concern of the central banks is the loss of control over their fiat currencies.
Yeah, I agree. It's what many people think of is the blockchain, but digital currency is not limited to just the blockchain implementation. So yeah, I agree, and it's even though it's a big struggle about control, I see more and more banks are warming up to actually embracing and utilizing, getting on the train.
Okay, David, would you like to take Uri's question as the last one? Or the point he's making, as it were?
Okay, the PGP is very risky to use for 20 years already due to the opinion of security services about PGP users. Is it not risky to use blockchain algorithms for the same type of projects?
Yeah, I think it's a good point and a good question. PGP is based on asymmetric encryption, certificates, and asymmetric crypto. For example, the RSA algorithm and ECC, elliptic curve cryptography. I would say quantum computing is a big threat against the RSA algorithm for reasonably long encryption keys. The next few years, and even if you switch from RSA to ECC, it's also I think it's vulnerable. So you need to move to, for example, lattice-based encryption that is used, for example, in homomorphic encryption implementations. So if blockchain is running into an attack by quantum computing, it will be, I think, very much similar to the attacks on other asymmetric algorithms that are used, for example, in PGP. So blockchain is using hashing to fingerprint the blocks to provide the integrity. And I think that blockchain probably will move to other encryption models over time. So when we work on the quantum computing risk study in ANSI X9. We pointed out migration recommendations. What algorithms or key lengths you should move to in a certain number of years. And I'm happy to have that dialogue. If you have special interest in that area, you can hit me up on LinkedIn, for example, or Mattsson on LinkedIn, or Mattsson with TTSS on LinkedIn, and we can have a dialogue about that. And in general, I think people need to prepare, even if it will take a few years before quantum computing will hit you or is able to hit you. It's advancing faster and faster. It's not just China. China is doing very impressive work on quantum computing. You have big players like IBM and Microsoft and others that are investing heavily in quantum computing, and the progress is I would say impressive. And Microsoft recently made a statement that within 4 years they will provide quantum computing as a service for the general public. So I think we should be aware that it will happen, definitely, maybe sooner than we think. So it's time to put a plan in place today, I think. Create the awareness, put a plan in place, so over the next couple of years you can migrate. It's not easy to migrate because, for example, the web is based on asymmetric encryption, RSA keys, certificates, and so SSL, TLS, based on asymmetric encryption. So it will take time before these products, or if you look at the vendor landscape with products, it will take time before these products have migrated. It will take time before you can have a certificate authority that is providing more than RSA-based key. For example, ECC, it was not easy to move to ECC, elliptic curve. It was hard to find a certificate authority for those certificates and encryption. And if we are moving to quantum safe algorithms like lattice-based algorithms, it will be another uphill or another wait until that is supported. So start your planning. It takes time to do that type of migration.
Okay, well, thank you very much, Ulf. That was really wonderful. And it's again shown what an expert you are in these fields. We really appreciate it. Thank you. And we hope to see you again pretty soon at another of these webinars, especially on items like, for example, you've mentioned quantum computing, another of the disruptive technologies which we need to learn more about. So please do join us for that. And as for you, thank you for attending this session. Thanks to my colleague David as well, of course. And we hope to see you soon at another of the webinars of the Central and North London branches of the BCS. Thank you. Goodbye. See you next time.